Good afternoon all. In the last class we have seen fuzzy sets problems and few numericals and fuzzy sets. What is the definition of fuzzy sets and fuzzy membership value, fuzzy elements, those things we have seen in the last session. So in today's session we'll see the membership functions and its features. So what are the membership functions? Like discrete continuous membership functions and what are its features, those things we'll see in this today's session. So there are two types of membership functions, mainly discrete type and continuous type of membership functions. So by the name itself you can understood that the discrete membership function means there are not continuous elements present in the on the x-axis. If you see that figure, y-axis represents the membership function, x-axis represents the membership elements, the corresponding elements. X represents the elements, y represents the membership function or membership value. That membership value is varying from 0 to 1. Mu a of x is nothing but here x represents the element, a represents the fuzzy set. In the fuzzy set A, there is an x element. X element may be varying from 0 to infinity on the x-axis. So likewise, the corresponding membership value on y-axis is 0 to 1. That is nothing but mu a of x is equal to, x is varying from 0 to 1, x is varying from 0 to infinity. So in this span, all the values in the discrete membership function are, that may be 0 or 1 or 2 or 0.5 or 6 or 7 or 6.5. So there are discrete values. There is no continuous element. There are no continuous elements or membership values also. That means elements means on the x-axis. Values means membership value or membership function means on the y-axis. So that means if any one of the axis is discrete means the second one or obviously it becomes discrete only. For example, number of elements. If you are representing that, those lines represent the discrete values. The corresponding point, at that corresponding point, for example, if you take the first line, at first line on x-axis some point if you take, at that point the corresponding membership value is at 0.25. It is between 0 and 0.5 means 0.25. The second line represents the second point on the x-axis, second element on the x-axis. That means in the fuzzy set A, the corresponding element x on the second element on the x-axis, the corresponding membership value on the y-axis is 0.5. If you take the third line, it is third point in the fuzzy set A, the corresponding value, fuzzy function value or fuzzy value is 0.75. Likewise. So all these are discrete. So for example, if you take here which fuzzy set requires different classifications, that you can take it on the x-axis. Let us take fuzzy set A. It belongs to the classroom. So A is nothing but fuzzy set, that is nothing but classroom. So in that, on the x-axis elements means x-axis elements maybe boys, girls, number of rows in the classroom. So likewise different classifications we can give, right? So all those are discrete values. How many number of boys in the class? It may be 35. How many girls? 40. All those are discrete values. If elements are discrete means your membership function will be discrete. So I hope you understood that. Otherwise, if your membership itself it is discrete means your values will be discrete. If y-axis is discrete means x-axis also should be discrete value only. So if discrete, either function or elements are present in any function, means that is called discrete membership function. And what is continuous membership function? Continuous membership function means element should be continuous and also membership value also continuous. Elements on the x-axis, on the right side figure, if you see, elements on the x-axis should be continuous, as well as membership value also should be continuous. Here bell curve, like that, one function I have represented here. If you see here, if you take any value on the x-axis, the corresponding value on the y-axis is continuously showing. So there is no discrete. For example, on the left side figure, if you see, from one line to other line there is a gap, so that shows that that is not continuous. But here, from each point on the x-axis, the corresponding y values are joined with a line, that is continuous. That is basic difference. I think basic point, continuous and difference, what you can understood. So like here, there are discrete membership function and also continuous membership function. In the continuous membership function, you need to, if you have continuous values, then you can go for this continuous membership function. If you want to represent the same thing, or if you want to correlate the same thing with crisp sets and fuzzy sets, let us see the crisp sets first. So if we take the y-axis, that is mu of x is nothing but fuzzy function. The corresponding membership value is 1, 0 to 1 on the y-axis. The corresponding fuzzy set A elements are represented on the x-axis. If it is crisp sets, means either you should have 0 or 1. The elements corresponding membership value, either it belongs to 0 or 1. For example, if you take the dotted lines on the x-axis with blue color, so first dotted line, either the membership value should be lies on the x-axis with 0 point, or it should go to the 1 value. Only two values, 0 or 1 in the crisp sets. So that's why those blocks represent the different sets. So first, second, third, fourth block, and those things represent the different sets. But here, in each set also, for example, if first block represents A set, means in the A set, either the values belongs to the 0 or it belongs to the 1. Only yes or no option will be there in the crisp set. If you take the fuzzy sets, on the right side figure, if you see, the same thing. Again, on the x-axis membership, or the corresponding fuzzy set membership elements, on the y-axis the corresponding membership value. X-axis is represent the elements, y-axis represent the membership function or membership value. Okay, so here in the fuzzy sets on the right side figure, one is with blue color line, another one is with red color line. The blue color line represent one set. Let us assume that blue color line is with A set, and a red color triangular line represents the B set. So here A set and B set, both the sets are there, and if you take a particular element on the x-axis, let us take on the x-axis one point, first point with one vertical line, small vertical line with blue color I have mentioned. On the x-axis around 4 points I have mentioned. If you take the first point, the first point corresponding membership value is on the y-axis, it belongs to the A set, and the corresponding membership value is 1, and there is no B set element corresponding to that first point. If you take the second point on the x-axis, the small vertical line, second vertical line is nothing but, let us assume that as second point. If you take that second point, If you draw a small vertical line from the second point, it intersects both B set as well as the A set. That means it intersects both red color as well as the blue color, right? That means corresponding to that X element, second X element, you can find the value in both fuzzy set A as well as fuzzy set B. If we take the second element corresponding B fuzzy function value is, that may be 0.2 or 0.1, and corresponding to that second element on the x-axis, fuzzy set value, fuzzy set A value is 1, fuzzy set function or value is equal to 1. In the A set, the same value on the x-axis, the membership value is 1, whereas B membership value is 0.5 or 0.1. In a similar way, other points also. It means here for different fuzzy sets, you may get different membership values. So this is what the fuzzy set representation. So like this you can get different, and it can vary from 0 to 1 in that range in different fuzzy sets. For the same element you will have different values in different fuzzy sets. So that is possible in the fuzzy sets. Okay. So if you see the membership function features, few features of the membership function, there are mainly three types of membership function features or features of the membership function. One is support, another one is core, another one is boundary. So if you take the support, what is meant by support means set of all points such that mu a of x is greater than 0. I hope from the starting we are going through that term mu of x, right? Mu of x is nothing but fuzzy function. Okay, fuzzy function is represented with the mu, and the mu a means that belongs to the fuzzy set A. Of x means that x represents the elements. Okay, x represents the elements in the fuzzy set A. That fuzzy function is mu of x. So here, to be in the support region, what is that support region means? Mu of x should be greater than 0. If you see the figure, mu of x is represented on the y-axis, that is nothing but membership value 0 to 1. On the x-axis, the corresponding elements. If you see that bell curve, in that bell curve, all the values on the x-axis under that bell curve, all the membership value for that x values on the x-axis are greater than 0. That means if you see that two arrow line, between that two arrow line, for each x value the mu of x is greater than 0 only. It may be 0 0.1, 0 0.2, 0 0.5 or 1. Again it is decreasing 0.9, 0.8, again it is coming to the 0. By excluding that 0, all that means both the endpoints of that bell curve, remaining all the points belongs to the support A only. That's why in the rectangle box represented with that support A, support of A is equal to x such that mu A of x is greater than 0. All the values if greater than 0, mu of x membership values are greater than 0, that region is called the support region or support feature. Second one is core. Here core means set of all points such that mu A of x is equal to 1. So earlier in the support it should be greater than 0. In the core mu a of x value should be equal to 1. It should be equal to 1. That means if you see the figure, mu a of x in that co-region, again two arrow line of that square or rectangle on the figure, it is all that region belongs to 1 only. Like here crisp set, either 0 or 1 is there. Before that co-region and after that co-region, there is a 0 point. Membership value is 0. But between that lines, it is 1. So that value is belongs to the co-region. So core of A is equal to x such that mu A of x is equal to 1. Okay. Your membership value always it should be equal to 1. Then it belongs to the co-region. If your membership value is always greater than 0, whatever the portion it belongs to greater than 0, that is nothing but support of A. And next one is boundary. The boundary we will see these two again. So boundary means set of all the points such that 0 is less than mu of x is less than 1. Here less than 0 is less than mu of x and less than 1, not less than or equal to. Here 0 is less than mu of x is less than 1. So if you see that figure, in that figure again mu of x is represented on the y-axis and elements are represented on the x-axis. The maximum membership value is 1, right? So here if you see the first portion between the dotted lines, between the first two dotted lines, vertical dotted lines, if you see that portion is belong to the boundary. Why? It means, what is the boundary condition? 0 is less than mu of x is less than 1. And if you see that line between the first two vertical lines of that figure, which I have mentioned with boundary, there your membership value is between 0 to 1. You can get the values between the 0 and 1, 0.5, 0.3, 0.99, 0.8 and so on. All those values you can get between that two vertical lines. That's why that is called boundary as per the condition. Again the same boundary line you will get between the last two vertical lines also. There also your membership value is varying between the 0 to 1. But if you see the again that horizontal, that means core region between the middle two vertical dotted lines, if you see, that is represented with the core, right? What is the core? Core of A is nothing but mu of x is equal to 1. In that region only your membership value is equal to 1. And what is support? Support means mu of x is greater than 0. The entire graph is greater than 0 only. That's why from first vertical line to last vertical line, it is represented with the support region. Mu of x is greater than 0 only, right? What is the difference between the boundary and support means? Support means mu of x is greater than 0 only. Mu of x is greater than 0 means it is including with 1 also. But boundary means between 0 and 1. That's why that one region is not including for that boundary. But for support it is including the boundary and core. Support is nothing but boundary plus core is nothing but support. Boundary is nothing but less than 1 and greater than 0 portion only. So if you see the figure properly with the definitions, you can understand that what is support, what is core, what is boundary. So these are the various features of the membership functions. Thank you all.